Molecular compounds. We can't just look at the elements in a molecular compound and figure out how they're put together because there's no charges involved. And you can have many different molecular compounds between the same two elements. We have an example here of nitrogen and oxygen, and they form all of these compounds. There's 1-to-1, NO, there's NO2, there's N2O, there's N2O3, N2O4, and N2O5. How do you know which one you're talking about? So we can't just call this nitrogen oxide or something because we're not going to know which one it is. Carbon and hydrogen are the real famous ones. They form gazillions of compounds, all with the same two elements. Well, we are going to name binary molecular compounds. So binary 2, molecular nonmetals. So this system of naming tends to be the favorite of students, and they want to apply it to everything, and you can't do that. So you can only use this to nonmetals. If you have a metal and a nonmetal, can't use it. You've got 3 nonmetals, can't use it. 2. We use numerical prefixes to tell us how many of each. We have to decide which element to go first, and so generally we put the more metal-like element first. So usually this is going to be the element with the smallest group number, or if it's 2 elements in the same group, then the element with the greatest row number. So that's all very nice, but I prefer to look at the periodic table and which one is closer to the metals. You know, if you're comparing oxygen and sulfur, well, it's getting more metallic as we go down. Sulfur is closer to the metals. It's going to be more metallic. If you're comparing, carbon and nitrogen, well, carbon's closer to the metals, so it goes first. So this is the general form, a prefix indicating the number, and that'll be right on the name of the first element. It's not real obvious here, there's a space there. And then the second word is a prefix indicating the number of the second element. We change the ending of the second element to "-ide". Now, again, with the prejudice against the number 1, we extend that to the prefix mono. If there's only one of the first element, we don't put mono. So NO2, there's 1 nitrogen. We don't say mononitrogen, we say nitrogen dioxide. So NO2, nitrogen dioxide. These two you also have to memorize. H2O and NH3. They always use their common names. H2O is water, NH3 is ammonia. Those names are very, very old, and so we just always use them. But it's always fun to freak people out and say, I had a big glass of dihydrogen monoxide today, and I lived to tell about it. You drank a glass of water. Silly. You just have so much fun with people. So let's practice. Name the following compounds. Ni3. Well, the first, it's always good to check and make sure that these are in the right category. Non-metal, non-metal. We're okay. There's 1 nitrogen, so we're going to skip the mono and say nitrogen. And there's 3, so triiodide. Now that looks a little weird, doesn't it? The 2 I's right next to each other. Yeah, we just have to get over it. What we'll see is sometimes we'll drop one of the extra vowels in there, and sometimes we won't. And I will try not to trick you on things like that because there's not an easy rule that I can tell you. And I've some of them I could say, well, I've seen it both ways because people do it both ways, even in textbooks, which is a little annoying. But nitrogen triiodide. PCl5, what would that be? phosphorus, pentachloride. Phosphorus, penta. The prefix just smashes right up to the second element's name, pentachloride. Well, P4S10. Tetraphosphorus, because there's more than one of that first one, so we do need the prefix. Tetraphosphorus, decaoxide. These A's are more likely to be dropped, so you may see decoxide. If this was a written out exam question, I would accept either decaoxide or decoxide. Yes? No. Thank you. Wow. Okay, so in my defense, I'm zoomed in and I can't see the S. Thank you. Deca. Now I'm writing with the eraser. Decasulfide. Yeah, way to go. Decasulfide. That's better. Okay. CO. Carbon monoxide. Carbon. Now that looks really weird, doesn't it? That looks like carbon monoxide. We generally drop the double O. Carbon monoxide. Silent killer, definitely. Write formulas for the following compounds. Carbon tetrachloride. Students like these because it's just more straightforward than the whole ion thing. So what's the symbol for carbon? C. Tetrachloride means 4 chlorines. So Cl4. Be careful when you're handwriting that your letters are appropriately sized. Because, carbon monoxide is CO, and C little o is something else. That's the element, cobalt, right? So we don't want to get those mixed up. Dinitrogen monoxide. What's the formula? N2O. Carbon disulfide. Start with the C and end it with the S. You have to do them as separate letters. Carbon disulfide CS2. Selenium hexafluoride. SEF6. Now, selenium is really close to those metalloids, isn't it? And occasionally we run into naming compounds where we've got the metalloids, like silicon, germanium, arsenic, antimony, tellurium, and then what do we do? What seems to be the pattern is if it's on the nonmetal side of the line, name it as a nonmetal. If it's on the metal side of the line, name it as a metal, even though we recognize that they're semi-metals or metalloids.